Engineering Geology, Unit 1, Introduction to Geomorphology and Hydrology. What is meant by geology? Geo means earth, logy means structure. So we study about earth structure, that is called geology. Geology plays a very important role in the field of civil engineering. It provides knowledge about materials used for construction. Its knowledge is helpful for constructing dams. Geotechnical engineers need knowledge about this subject for excavation, digging work. Its knowledge is required for foundation faults, for designing highways and roads. In construction of tunnels, soil tests are done before any project. In civil engineering, like roads, dams, tunnels, etc., are built upon the earth surface. Engineering geology aims studying the geological and geotechnical conditions of the terrain where the major engineering structures have to be built safely and economically. Rocks and soil are the basic sources of construction materials. The geological conditions of the project site may influence the engineering problems which have to be overcome. The engineering geologist observes and records geological information by his geological field work, and mapping of translates his idea to practical engineering design, construction, and maintenance of civil engineering projects. Generally, the engineering geologist of the project site approaches the project civil executive engineer and presents field geological maps, geological cross-sections of the construction site, borehole, etc., for obtaining final approval for commencement of the project. A trained civil engineer understands all the field geological problems and interprets the submitted geological documents to the further effective action for yearly clearance, approval, or rejection of the projects. In major civil engineering projects, civil engineers and engineering geologists work together at different levels, starting from the planning stage to the construction and maintenance stage. The responsibilities of the civil engineer and the geologist in the few fields are listed below. These are the main and allied branches of geology. First thing, main branch. Main branch is physical geology, mineralogy, petrology, structural geology, historical geology, paleontology, economic geology. Allied branch of geology is engineering geology, mining geology, geophysics, geohydrology, and geochemistry. What is meant by hydrological map? Hydrological map means groundwater is one of the major problems in most of the subsurface engineering projects. For example, groundwater problems in Neyveli lignite mining, Neyveli groundwater in artesian conditions. For any subsurface civil engineering projects, hydrological parameters such as porosity, permeability, aquifer characteristics, water table maps, etc., are to be studied in detail before the execution of work. Dams and reservoirs. Civil engineering related projects such as dam and reservoir. These are all the main huge projects like dam, tunnels, road and highways, bridges. For example, dams and reservoir, what are the things we need to consider before the construction of dam? First thing we need to consider main topographic features and natural drainage pattern, then structural characteristics of rock formations such as their strike and dip, folding, faulting, and igneous intrusion, rate of weathering and erosion in the site, lithology and engineering properties of rock, and groundwater conditions. For obtaining these details, conventional geological and geophysical surveys have to be conducted. Then tunnels. For a construction of tunnel, before that, we need to learn about the general topography, composition of attitude and altitude of rocks, then structural characteristics of rock like fold, fault, joint, like that, then hydrological conditions and borehole sampling. And the main thing, roads and highways. Road and highways, before we start the work, what are the details we need? Topography or landform of region, lithological and structural characteristics of rock, soil and groundwater conditions, and status of weathering. These are all the details. So that's why we need to study about engineering geology in civil engineering. Then branches. First, physical geology. What is meant by physical geology? This is also called as dynamic geology or geomorphology or general geology. Physical geology deals with the different physical features of the earth, such as mountains, rivers, lakes, glaciers, and volcanoes. Physical geology deals with the study of geological work of the physical and natural forces which move the surface of the globe through their ceaseless action through ages. Thus, the work done by blowing wind, river, and underground water, oceans and seas, glaciers, earthquakes, volcanoes constitute the subject matter of physical geology. Natural phenomena like landslides, earthquakes, and weathering is also the physical geologist changes. Next, mineralogy. This deals with the study of minerals, that is called mineralogy. Mineralogy studies about the mineral structures, physical, optical, and chemical properties, their mode of occurrence, and mutual association. It also deals with the descriptions of the individual distinguishing characteristics of the mineral species. Mineralogy also strength and durability of the material and chemical composition. The quartzites and marble resemble one another in shine, color, and appearance, but quartzites, by virtue of its mineral composition, is very hard, tough, strong, and durable, while the marble disintegrates and decomposition in a short period because of its mineral composition and properties. Next, petrology. Petro means rock. In Italian, petro means rock, logos means study. So, petrology means study about rocks. The earth crust is also called as lithosphere. It's made up of different types of rocks. Petrology deals with the formation, structure, texture, composition, occurrence types, etc. That is petrology. Petrology means study about rock like igneous rock, metamorphic rock, and sedimentary rock. Petrology is the composition and texture characteristics of rocks primarily contribute to their strength and durability. Rocks based on their suitability can be used for foundation, for dams, tunneling, and other construction materials. Hence, it is most important branch of geology from civil engineering point of view. Next, structural geology. Structural geology deals with the study of structures found in rocks. It aims at investigation and interpretation of structural features like fold, fault, joints, etc. in the rocks forming the crust and also their possible mode of mechanism of formation. The rocks which forms the earth crust undergoes various deformation, dislocations and disturbances under the influence of tectonic forces. The result is the occurrence of geological structures like fold, fault, joint, and unformities of the rock. The detailed mode of formation, causes, types, classification, important, etc. This is the structural geology, like faults. This is fold of the geological structures. Structural geological structures modified in the inherent physical characteristics of rock, rendering them more suitable or unsuitable for civil engineering purpose. Dam site sedimentary rock with upstream dip provided a desirable geological setup, while the same rock with a downstream dip make geological setup and undesirable. Next, historical geology. Historical geology deals with the past history of the earth as deciphered from the study of rocks and features associated with them. Rock source and possesses many evidence within them. Fossils remains of ancient plants and animals are indicative of paleo elements and the area of their occurrence. So, rocks are treated as pages of Earth history. Paleogeography, paleontology, and stratigraphy are three distinct subdivisions of historical geology. The Earth's surface was always suitable condition for the deposition of sediments at some place or other place. Therefore, there are sedimentary rocks of the Earth representing the entire period of the Earth history. Proper investigation of these rocks reveals the chronological sequence of formation of rocks, evaluation, migration, and plants and animals' life during different periods of the Earth history. This kind of study of the Earth history through sedimentary rocks is called historical geology. Next, economic geology. Minerals can be grouped into rock forming mineral and economic minerals. Some of the economic minerals like talc, graphite, mica, asbestos, gypsum, magnetite, and diamond are useful as raw materials in some industries. Economical geology deals with the study of commercially valuable mineral ore deposits, including metallic and non-metallic minerals like coal, petroleum, natural gas, atomic minerals, etc., which can be exploited for the benefit of man as well as for the development of the economy of our nation. Mode of occurrence of such mineral deposits, their properties, principles involved in their formation, etc., are dealt with the economic geology. Economic geology, the prosperity of a nation depends to a large extent of rich reserves of economical minerals deposit. Gulf countries are rich because of their oil deposit. South Africa is rich because of its gold and diamond deposit. It deals with the mode of formation, occurrence, classification, association, varieties, and concentration, properties and uses, etc. It is related to economic importance. It is not related engineering point of view. Next, engineering geology. This deals with the application of geological in the field of engineering for execution of safe, stable, and economic construction in like dams, bridges, and tunnels. Engineering geology is dealing with the application of geological in engineering. It deals with the geotechnical and geophysical studies for selection of sites and locations for the major engineering projects on one hand, and with the availability of materials of required quality for constructions on the other hand. Overall, it aims at safe, stable, and economic design and construction of your civil engineering projects. Next, allied branches of geology, that is mining geology. Mining geology applied to mining and quarry practices, that is the exploration and exploitation of economic mineral deposits is studied under this project. A mining engineer is interested in the mode of extent of occurrence of ores, their association, tenor, properties, etc. It is also necessary to know other physical parameters like depth, direction, that is strike, inclination, that means dip, thickness, and ore bodies. This is the mining or quarries. Next, geophysics. Geophysics, the study of physical properties like density and magnetism of earth. It is subdivided into pure geophysics and exploration geophysics. Pure geophysics deals with general aspects of earth as a whole, and exploration geophysics deals with the study of upper layer and of the earth crust in order to solve civil engineering problem and locating oil, gas, and groundwater explore and estimate the ore deposit. This is the pure geophysics. We study only about the crust of the earth. Next, geohydrology. Geohydrology, this may also called as hydrogeology. It deals with the occurrence, movement, and nature of groundwater in an area. This branch is closely related to geology because the very existence movement of groundwater are directly related to porosity, permeability, structure, texture, and composition of groundwater and underground rocks. This is the underground confined aquifer, unconfined aquifer, confirming bed. There's a study about the hydrogeology. Scope of geology. Geology provides necessary information about the construction materials at the site used in construction of buildings, dams, tunnels, tank, reservoir, highways, and bridges. Geological information is most important in planning stage, design phase, and construction phase of the any engineering projects. Geology is useful to know the method of mining rocks and mineral deposits on earth surface and subsurface. Geology is useful for supply, storage, and filling up reservoirs with water. This is the only subject which gives the information about the earth structure. Next, importance of geology in civil engineering. Before constructing roads, bridges, tunnels, tanks, reservoirs, and buildings, selection of site is more important from the point of stability of foundation. Geology provides a systematic knowledge of construction materials and their properties. The knowledge about the nature of the rocks in tunneling and construction of roads. The foundation problems of dams, bridges, and buildings are directly related with geology of the area where they are to be built. The knowledge of groundwater is necessary in connection with excavation works, water supply, irrigation, and many other purposes. The knowledge of erosion, transportation, and deposition. Shortly, it is noted as ETD. By surface water helps in soil conservation and river control. Geological maps and sections helps considerably in planning many engineering projects like tunnel construction, bridge construction, and reservoir construction, highway construction, like that. If the geological features like fault, joints, fold, are found, they have to be suitably treated. Hence, the stability of the rock structures is more important. Pre-geological survey of the area concerned reduces the cost of planning work. Any rocks which is hard and strong, it may be decided when it is exposed to the atmosphere, ultimately making the rock unfit to be at the site of foundation or to be used as a construction materials. Deals with response of different minerals which constitute the rocks will give the proper understanding of the weathering phenomenon. Hence, the weathering of rocks is studied in general geology. Weathering of rocks. The process by which rocks are broken down and decomposed by action of external agencies such as wind, river, rain, temperature changes is called weathering. Weathering is classified into three types: mechanical weathering, chemical weathering, and biological weathering. Mechanical weathering is also called as physical weathering. This process involves breakdown of rocks into smaller pieces due to natural forces like waterfalls, landslides. The different types of mechanical weatherings are frost wedging, expansion and contraction, and effects of vegetation. Frost wedging. The presence of water in the cracks of the rocks freezes during the night time and melts during daytime. Freezes of water involves an increasing volume because of which walls of cracks are wedged ultimately results in breakdown. It is called frost wedging. This is the process of frost wedging. First, the rocks having cracked, the water enters into the cracks, freezes at night time, and expands the cracks. Cracks deepen, more water enters and freezes. Repeated freeze and thaw breaks up to the along the joints, the rocks broken into smaller pieces. It is called frost wedging. And expansion and contraction process. Solar radiation causes heating, which results in thermal expansion during daytime and drop in the temperature during nighttime causes contraction. The expansion and contraction are confined only to the surface layers to the rock and results in fracture. This is the expansion and contraction weathering example. Next, effect of vegetation. During the growth of vegetation in rocky terrains, the roots penetrate into the existing weak plains and gradually the cracks are widen, leading to physical breakdown of rock masses. This is the example of effects of vegetation. Next, chemical weathering. Chemical weathering. Chemical weathering involves chemical reactions resulting in the alteration of the rock, leading to the formation of new alteration products. Water is the best fluid that directly affects rocks by the way of dissolution, leaching, hydration, oxidation, dissolution. In case of carbonate rocks such as limestone, dolomite, marble, when the river water travels in these rocks, carbonates are dissolved, resulting in the reduction of their sizes. This is the example of resolution and leaching. Leaching means removal of soluble content from the rocks by water. Water is the powerful leaching agent which affects leaching for the most of the materials when come in contact with water. This is the examples of leaching and hydration. Hydration, ions have the tendency to hydrate when H2O is present and dissociate. This kind of weathering happens in arid environments where salts are present. For example, chlorides and sulfates weather due to hydration. In general, iron with same charge but smaller ion radius have a larger layer of H2O ions and therefore do not tend to absorb tight. The small ion tends to remain hydrated to the surface, whereas a large Al3 ion tends to dehydrate and become tightly absorbed. The strength of absorption increases the following sequences, that is hydrolysis, etc. Okay, this is called hydration. Next, biological weathering. Biological weathering, it involves breakdown of rocks by living organisms like bacteria and fungus, acid, amic acid, etc., which cause decomposition of rocks. Some of the microorganisms penetrate into mineral crystals and remove specific ions from the internal layers. This is the biological weathering. Next, we study about earth structure. In earth structure, it is divided into three categories, that is atmosphere, lithosphere, and hydrosphere. Atmosphere. Atmosphere means this is the outer layer of earth. The atmosphere is a thin layer of gas which surrounds the earth. There are two most important layers known as troposphere and the stratosphere. The surface and extending so far as 700 kilometers and even beyond is termed as atmosphere. This is the atmosphere. First, this is the troposphere, stratosphere, mesosphere, thermosphere, and finally exosphere. Troposphere. Troposphere is the lowest layer of Earth atmosphere. Up to this is having 11 to 12, 20 kilometers. Its upper boundary called tropos about 9 kilometers above the poles and at 18 kilometers above the equator. And stratosphere. This is the troposphere. Next, stratosphere. It is the second layer. It is the second layer of the atmosphere, starting from the tropos and extending up to an average height of 50 kilometers. The temperature becomes constant for a height of 20 kilometer and then starts increasing. The ozone layer starts at a height of 9 kilometers above the surface and continues up to 35 kilometers. This stratosphere and mesosphere. This is the third thermal zone of atmosphere, which begins at stratosphere at about 50 kilometers above the surface and continues up to a height of about 85 kilometers. It is characterized with a steep fall in temperature that may go to as low levels as 100 degrees Celsius at the upper limit of mesosphere. This is mesosphere and thermosphere. The fourth and the last zone of the atmosphere starts at about 85 kilometers and extends up to 690 kilometers. In this zone, temperature starts rising once again and reaches 1000 degrees Celsius and above. Atmospheric gases at these heights absorb a great part of solar radiation coming to the Earth. This is exosphere, and this is the Earth interior structure. Now we have seen about Earth above structure. Now we have seen into Earth interior structure. In Earth interior, the first layer is crust and lithosphere, asthenosphere, mantle, outer core, and finally inner core. First, lithosphere. The term lithosphere is now understood to include only the uppermost shell of the Earth, the crust, and a part of the second layer, the mantle, up to which the material exists in a definite solid state. This crust. This is the inner structure of Earth. The first top layer is the crust. The crust is the thickness is about 0 to 100 kilometer. After the crust, this is called asthenosphere. Then here this two this is known as mantle. Okay. Then outer core about 2900 kilometer. This is called outer core, and 5100 kilometer. This is called inner core. Okay. This is the Earth structure, crust. It is the uppermost solid shell of the Earth, which has varying thickness in different areas as follows. Under the ocean, averagely 85 to 6 kilometers. Under the continents, it's varying 30 to 35 kilometers. And under the mountains, it goes to up to 60 to 70 kilometers. Earth structure, oceanic crust. Crust beneath the oceans consists mainly of dense rock, that is basalt, dark in color, then 5 to 6 kilometer thick. Continental crust that forms the continents consists mainly of less dense rock and 35 kilometer average thickness. Next, mantle. Mantle, layer of rock between crust and core, that is about 2900 kilometer thick. More than 67% of Earth mass runs in the mantle. Composition of mantle is silicon, oxygen, iron, and magnesium. Physical conditions of mantle change because pressure and temperature increases with depth. Temperature changes from 870 degrees Celsius to 2200 degrees Celsius in the mantle. Next, core. Innermost layer of the Earth is called as core. Core is about 6,800 kilometers in diameter. 1/3 of Earth mass, that is 15% of its volume, having in the core portion. Core portion having temperatures 2000 degrees Celsius to 7000 degrees Celsius. It consists of two parts, that is inner core and outer core. Outer core is between 2900 kilometer to 5000 kilometer. Layer of liquid and iron and nickel beneath the metal. surrounds the inner core is 2200 kilometers thick. Next is inner core. Inner core 5000 to 6370 kilometers. Dense ball of solid metal. Extreme pressure from layers above 1200 kilometers from outside edge of inner core to center. Next, we study about tectonic plates. This goes to up to. Let's see about the next class. Thank you.